Good day, students. Today we are going to talk about alcohol, the homologous series alcohol. Okay, there is something common about compounds that belong to the same homologous series. Okay, in most cases, compounds that belong to the same homologous series will have the same functional group. And when we say functional group in organic chemistry, we are saying the functional group is the reactive part of the organic molecule. So when you look at alcohols, you're going to find out that they have a functional group OH, 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 OH. Okay, the way we name them will end up with the suffix will always be "ol". So we have a general formula for the general structure for alcohols. We have the R group, which will be our hydrocarbon part, and at the end we have the OH group. So the first one will be methanol. Okay, when there's one carbon, the prefix will be meth. So this one is methanol. When there are two carbons, the prefix will be eth. So this one is the ethanol. When there are three carbons, 1, 2, 3, the prefix will be prop. Okay, so this will be propanol. So I have methanol, ethanol, propanol. Okay, that's how we name our alcohols. So if someone were to say, what is the general formula of alcohols? The general formula of alcohol, we have to look at the link, okay, the relationship between the number of carbons, the number of hydrogens, and so forth. But let's us just say at the end here we are going to have OH. But let's see how the carbons and the hydrogens are changing in the R group, okay? If I have one carbon, I'm going to have 3 hydrogens. If I have 2 carbons, I'm going to have 5 hydrogens. If I have 3 carbons, I am going to have 7 hydrogens, okay? So there's a pattern which is repeating here. It appears that if I have a certain number of carbons, if I want to find out how many hydrogens I have, there's a certain mathematical procedure that I have to do in order to get the number of hydrogens, okay? So it appears as if I have to multiply by 2, and then I add 1, and then I get the hydrogens. I have 1 carbon, 2 times 1 is 2 plus 1 is 3. I have 2 carbons, 2 times 2 is 4 plus 1 is 5. I have 3 carbons, okay, 3 times 2 is 6 plus 1 is 7. So this one becomes the general formula for my alcohol, CnH2n plus 1. And then we get the answer there. If you are asked to write down the formula or the general formula of your alcohols, okay. Suppose now someone says, I have an alcohol whose MR is 116. Then they say, can you predict, can you show us what will be the formula of this alcohol? I know that all alcohols will be having OH, okay? So what I do first is I have to multiply the mass of oxygen and the mass of hydrogen from this, okay? So first of all, I will have to say, for me to determine the hydrocarbon part, I must minus, okay, 17. Why? Oxygen, the mass is 16, and hydrogen, the mass is 17, is 1. So 16 plus 1 is 17. So if you say 1 minus 17, you're going to get 99, okay? 99. After you have isolated the OH part. So this 99, I have to say, is coming from the hydrocarbon part. Remember from our general formula, the hydrocarbon part is always 2n plus 1. Okay, so if you have your 2n plus 1 here and you calculate your n, you're going to find out that your n here will come up as 7. Okay, and then if you then write down your carbons, when it's 7, you're going to say, if my n is 7, you're going to say C7, and then 7 times 2 is 14 plus 1 is 15. So C7H15 OH becomes my answer. Okay, so that's how you can handle that part where they say if the MR is 116, isolate OH first, and then you determine what is N by using that equation. I hope I've helped you to understand the basics of homologous series for alcohols. Bye-bye for now.